We will begin with plane mirrors in this topic on ray optics. Then we will talk about curved mirrors. These two things will be about reflection, and then refraction would come, and in refraction also you have flat surfaces, you have curved surfaces. In all these discussions, we won't be talking about what exactly light is made of, but the path that it travels. For that we will use rays and lines, and that will be enough to analyze these phenomena called reflection, refraction, which primarily we would be discussing in ray optics. There are other phenomena that light shows. For example, interference, and for that discussion it is necessary to consider the wave behavior of light, and that will be covered in a separate topic. When light is incident on an object, many things happen. One thing that happens is absorption. Why does a red color rose look red? It is because of absorbing other colors. Imagine some colors are hitting rose, and after hitting rose they reach your eyes, and rose is not allowing some colors to reach your eyes. It is just absorbing them. So you are able to see the color, you are able to call it red rose because it is absorbing other colors. So absorption is very common, and what you see objects having different colors, you can see that most things absorb different colors. Colors means different frequencies of light. Light is electromagnetic wave. It has got various frequencies present or various wavelengths present, and we are able to see a very small part of the electromagnetic spectrum. The electromagnetic spectrum is very wide. All the rays that you hear called X-rays, gamma rays, etc., they all are in it. They all have similar properties in the sense that they are non-mechanical. They do not require a medium to travel. They all travel with the same speed, which is the speed of light. Many things are similar in them, many things are dissimilar in them. Color is just one thing. For high energy purpose, some types of rays are used. Gamma ray is very high energy ray. some are low energy rays, and very small part of the rays is what we are able to see, we humans are able to see. That we call as the visible region. So when we say color, it means within that visible spectrum, lot of frequencies are being absorbed and only some frequencies are allowed to go away. Go away means reflect. We are able to see something because of rays reaching our eyes. And rays will only reach our eyes if that object which we are trying to view is reflecting the rays. And our eyes are able to catch those rays and brain is able to read those rays. I mean the signal that eyes send to the brain. Reflection means bouncing, and it is because of this that we are able to see something. In this topic we'll be talking first about mirrors. In mirrors you will have plane, you will have curved mirrors, and one universal law that would work is that angle of incidence is equal to angle of reflection. Whether it is a flat mirror or it is a curved mirror, angle of incidence is equal to angle of reflection. So the point where light hits, you need to draw a normal, and that angle I will be equal to angle R. So that is valid for both plane and for curved surfaces. Refraction. Refraction actually means speed. It means change of medium, and speed changes when the medium changes. So it is about speed change. Refraction is about speed change. It is about medium changing. And often this medium change is associated with bending. Often, not in all cases, but often it is associated with bending. If you look at something like prism, prism bends too much because in prism there are two surfaces where bending happens. So the bending eventually is too much. Lenses work on this principle of refraction. You can have flat type of things also, say water in a pond. So there can be flat thing also, or let me say a slab of glass. That's flat surface. It could be flat slab of glass. Water filled in beaker is also like flat. And curved lenses, concave lenses, convex lenses, and so on. So bending is a usual association with refraction, but if we look at all the three, then all the three are present. In most cases, all the three things of phenomena are present. So in real situation, even when you are looking at a mirror, other things are also happening. It is a question of which dominates and which you want to dominate. So some amount of absorption is always going to be there, some amount of reflection, some amount of refraction. But one can try to control different phenomena by coating, for example. In case of mirror, you coat it so well that it primarily reflects. So one can dominate out of these three. But most of the times, it is all the three. In this topic on ray optics, we are going to discuss those situations where the object is much larger than the wavelength of light. Object is much larger than the wavelength of light. And that happens very commonly. Even something like a small insect is too big for the wavelength of light. So this is not unreasonable to consider those situations where wavelength of light is much smaller than the object size. Let's talk more about reflection now. There are two laws of reflection. One law is that angle of incidence is angle of reflection. You know what angle of incidence is? Draw normal. This is a ray. This is angle of incidence. This is angle of reflection. Also remember that this law works for perfectly elastic collisions. In case of mechanics also, for perfectly elastic collision. But if collision is not perfectly elastic, then angle I would not be equal to angle I. That's one law. And then the two rays, incident ray, reflected ray, and this normal. They are in the same plane. Right? They are in the same plane. So this rule works for curved mirrors also. You can imagine some curved mirror here, and the same rules would work. No matter at which point the ray hits the mirror, at that particular point you can construct the normal and proceed. How are we able to see things because of reflection? First, we need some source of light. Let's say that source is sun. And suppose you're trying to see this object. So sunlight should be able to reach that object. Sunlight would hit that object, and after hitting it will bounce back. Some part of it will bounce back. Some part will be absorbed, and some part will bounce back. And in that bounce back part, some part, very small part, will reach your eyes. several people are able to see the same thing, right? So after the light bounces off or reflects, it goes in several directions. And depending on where eyes are located, you are able to catch those rays. So some rays reach the eyes, and that's how the object is visible. So a source of light should be there. If sun is not there, it's dark and it is outside object and no other source is there, then there are no rays for object to reflect. There are no rays for the object to reflect. So obviously it won't be visible. But even if rays are there, and if the object is reflecting also, your eyes may be located in some part where the rays are not reaching. Maybe some obstacle, imagine some big obstruction in between. So your eyes don't see the object. And just imagine if the object absorbs every single type of ray that sun is sending. If it absorbs every single type of ray, then it will not send anything towards your eyes. That doesn't happen normally. So I was talking about color earlier. Now, sunlight actually has many frequencies mixed, many wavelengths mixed. So when we say light is bouncing off this object, several frequencies are bouncing off that object, and your eyes are able to catch multiple frequencies. Now imagine there were, I'm just using some hypothetical numbers. Imagine there were 4 frequencies only, and 3 are absorbed, only 1 is allowed to reflect. Only 1 is allowed to reflect. 3 are absorbed completely. So whichever is reflected, that frequency your eyes will catch. Eyes will convert that reading to electrical signals, then brain, the signals will reach the brain, then brain will see actually. Brain will read and see. And it will see some color. And that color is because of this frequency. 3 are not able to reach the eyes. So why does something look blue? Even though sunlight has many other colors present, something looks blue. Because other colors present in the sunlight are absorbed by that thing which we are calling as blue. And then blue color is getting reflected and our eyes read it. I mean our brain reads it eventually and we call it blue. So if you must be aware of night vision glasses. And also other techniques of seeing. Using ultrasound, you can see something inside the body. Using X-ray, you can see something inside the body. Using thermal imaging, night vision glasses, you can see something. So our eyes have very limited seeing capability, very limited in the context of the universe. In the context of living beings and mammals, it's very advanced. Now imagine some way you can read X-rays. Eyes cannot read X-rays, but some way you can read X-rays. Then infrared rays our eyes cannot read, but some way you can read infrared rays. Then in pitch dark, visible, nothing. But infrared is not visible. But suppose you can read infrared, then you can see in the dark. So these things have been going on for a while. There are different rays which are involved for these things. It's all about reflection and catching. So reflection is responsible for allowing something to be visible. We are also able to judge the location of the object which we are able to see, and that judgment is due to the direction of rays, where the rays are coming from. So from that we are able to judge the location of the object. Consider some object located here. This is the plane mirror. Consider some ray, any ray of your liking. It hits, bounces back following the law of reflection. This has been intentionally extended. Take a second ray, anywhere. There will be too many rays that one can consider. Two are enough. Extend that also, or extend any other one of your liking. You can draw as many as you wish. Now, extending two is enough. And you find that they intersect. That's where you get the image of that tip. So what this eye, or rather brain, what this brain thinks is that the object is here. All rays will appear to come from the same point, all rays. Whether you take this or this, anything else you choose to take. Now, an object has too many particles in it. Now, practically, it would be very time consuming to take all of them. So normally we take one or 2 points and do this type of construction. So normally you would see that we don't consider other points, but in reality each point is going to reflect light which is coming from sun, and that light will go like this, get reflected from the mirror, will reach the eyes. So in a ray diagram, we generally don't complicate things by taking large number of points. What is really convenient is this second ray. You need two rays, right? This case becomes very convenient case, theta equal to 0. I mean I equal to 0, r equal to 0. And second ray at some angle. So imagine we take that theta equal to 0 case. It will go straight, hit, go straight, back. This is a very convenient case, extended by dashed line. Second one you can take at any angle of your liking. Say it is this. And that will have to be extended. D, it's the same D which is here. D behind. So that's the property of plane mirror. Image is formed at the same distance behind. It is of the same size. Now right side there is no place for the rays to exist. There is no place for the rays to exist. So this is called a virtual image. So this is a virtual image. Rays cannot exist on that side. It's a block. So for a real object, the image is virtual at the same distance, same size. Taking more rays is completely optional. Have you noticed some ambulance? What it actually reads? It would read something like this, what you see here. Now this is just a summary of the type of image. Straight, it's not downwards, same size, same distance, but behind virtual. Virtual, but for real object, it's virtual. Left-right inversion. I hope you understand this point. If you don't understand this point, raise your hand. I will try to explain this. Okay. Now, why do ambulances have ambulance written backwards? What do you think? That's fine, but whose mirror are you talking about? That's right. Driver ahead. Driver ahead. So some car is in front of the ambulance, and ambulance may be in a hurry. Ambulance may be in a hurry. So the driver in front of ambulance may realize this, reading on his rear view mirror, and may give the space so that the ambulance can travel quickly. Okay, now consider this particular drawing, and there's a dog called Tommy. Can this dog be seen? That's the question. Exactly in this situation. Now to answer that, you will have to do the drawing, ray tracing. So mirror has various regions to reflect light. If any region is able to send light to the eyes, any region, this region, this region, this region, then the person is able to see. But if no region of the mirror is able to send light to the eyes, not possible. Of course, directly the person can see Tommy's tail directly. We are not talking about direct ability to see it directly, but we are talking about ability to see the reflected thing. So when you consider this ray, well, that is very wide, this wide. And this also, I think, doesn't have a chance to reach anywhere near the eyes. Okay, that's more accurate, what you can see now. So no chance. The whole mirror has been covered and rays are not going towards eyes. Not possible. Well, note it down. This is your assignment question. You are standing in front of a short flat mirror which is placed too high. So you can see above your head, but only down to your knees. To see your shoes, you must move. 3 options. Multiple mirrors. When we have multiple mirrors, then image formed by one mirror can act as an object for the other mirror. Image formed by one mirror can act as object for the other mirror. So here, this is one mirror, this is another mirror. So one image will be here, another image will be somewhere there. But this image by this mirror will act as object for this. And when you have this type of situation, this is the mirror and this is the object. Object can be on the right side of the mirror, on the left side, no problem. Still, image will be here. Object, image. So this will act as object for this mirror and image will be somewhere here. And likewise this will act as object for this mirror, but then you will find that it will make the image at the same point. So there won't be 4, but there will be only 3 images overall. The other way to think is of double reflection. How is the third image formed? One way is to think that this will act as object for this mirror, or this will act as object for this mirror. That's one way. Other way is to consider double reflection. Number 3. You are seeing two plane mirrors 90 degrees to each other. A ray of light is incident on the horizontal mirror at an angle theta. For what value of theta the ray emerges parallel to the incoming ray after reflection from vertical mirror. So it will bounce two times here and here. We want the final ray to become parallel to this. So at what value of theta will it be possible? 60, 30, 45, all of the above. We want the final ray to be parallel to this. So theta should be what? Yes, I think in class 9th geometry, this is the problem that proves that the final ray is parallel to this ray. Angle doesn't matter. Whatever angle you take, it has to be so. All. Raise your hand if you would like this to be discussed. There are two plane mirrors, these two. This is the ray which is coming parallel to the mirror, parallel to the surface of this mirror, hits this mirror, and finally it comes out parallel to this. Finally it comes out parallel to this. Then theta is 90, 60, 45, 30. It's a geometry, basically, geometry problem. If these lines are parallel, if this is theta, won't this be theta? And if these lines are parallel, if this is theta, won't this be theta? But if this is the incident ray, this is the reflected ray, then won't these two angles be the same? In law of reflection, you can also say these angles are equal, isn't it? When we say these angles are equal with the normal, doesn't it mean that these two are also equal automatically? If this is theta, this will be theta. If this is theta, this will be theta. Any questions? Let me know. Fine. We stop now.